Greetings to all. My name is Paul John, and this is my 10th e-record, the 10th experiment in the data structures lab. Now, this exercise is based on implementation of insertion and displaying in binary search tree. Now, binary search tree is a binary tree in which the nodes are arranged in such a way that all the nodes lesser than the root node is to the left subtree, and all nodes that are greater than the root node is to the right subtree. Now, without further delay, let's move on to the tree, the code that I've created. This is the code that I've created. Um, I've declared the necessary header files, and then I've created a structured tree with int data, tree pointer left, and tree pointer arrow right. Then I've declared necessary functions, which we'll talk about later in detail in the code. Now in the int main, I've declared necessary variables, and then I've asked the user what he wants to do, whether he wants to insert or whether he wants to display. Now I use a switch statement to take the choice. If the choice is 1 and then insertion takes place, I ask the user to enter the key, and then I call the insert tree of function root comma key, and then if the option is like if the choice is 2, then displaying takes place. And then I use a do loop to ask the user whether he wants to continue, and if his answer is like not y, then the program ends. Now moving on to the functions that I've created. This is the void insert tree function with arguments tree arrow base and int item. First we check whether the tree is empty. If so, we just directly insert the element, that's temp equal to new tree, that's new node is created, and then that data is equal to item, then the left pointer is null, right pointer is null, that's this one, the right pointer is null, and then I initialize root equal to temp, I make root point temp. And if that's not the case, that is if base arrow data is equal to item, that is the item is already present. If so, then I print item already exists. If that's not the case, now we check whether base arrow data is greater than item. That is, if the item we need to insert is less than the root item we have. If so, we have to insert in the left subtree. Now we check whether base arrow left is not equal to null. If it's not equal to null, then we start a recursive module which goes all the way through the left subtree as long as it's not equal to null. The left pointer, like the left node of each node is not null. And once it's null, it comes out of that and initializes that value, the new temp, into that area, into that pointer again. Now this is a recursive function, this is a recursive function. Now after that, else if base arrow data is less than item, that is the item we have inserting is greater than the base, in that case we check whether if base arrow right not equal to null, and we use a recursive function in ins tree base arrow right comma item. This traverses all the way through the right subtree and finds the right position, and if that's not like, and then when it comes out of that, then we insert the node into that position. Now void display, like we can display tree in 3 ways, that is in order method, post order method, and pre-order method. Now first we check whether the root is equal to null. If so, then the tree is empty. If that's not the case, then we ask the user how he wants to display it, whether in order or pre-order or post-order. I have declared 3 functions for each of the orders. Now let's move on to the functions. Void in order, tree arrow temp. Now if temp not equal to null, like in order, it's like left, data, and right. So first we go through a whole of the subtree, left subtree, that's in order of temp arrow left, and then we print the temp arrow data, and then we go through in order temp arrow right. Now void pre-order tree pointer temp. In pre-order, the order is DLR, that's data, left and right. So we print the data first, and then we go pre-order temp arrow left, that's whole of the left subtree, and then we go pre-order temp arrow right, that we go whole of the right subtree. Now void post order tree arrow temp. In post order, the formula is like left, post order it's left, right, and data. That is, first we go through the left, and then we go through the right, that's this one, and then we print the data. That's it, that's the end of the whole program. Now let's try whether my function runs. All my program runs perfectly. The compiler is asking me to give 1 minute, let me just maximize this one. Okay, the compiler is asking me for my choice. Let's try to display something. The tree is empty. Yes, I want to continue. Let's try inserting something. Let's say 50. Yes, I want to continue. Let's insert something more. Let's go with 90. And then, do you want to continue? Yes, I want to continue. 1. Let's go with 30. Continue. Yes. Let's try one more. Let's go with 28. Continue. Yes. 1. Now let's display. Now they're asking me how I want to traverse the tree. 1 for in order, 2 for pre-order, and 3 for post order. Let's try in order. Now the thing of a binary search tree is when you traverse it in order, we get the increasing order, that ascending order. So that's it, 28, 30, 50, and 90. So now yes, I want to try. Now let's try the next one. Let's say pre-order. That's 50, 30, 28, and 90. Now let's try the next one. That will be 3 post order, 20, 30, 90, and 50. So all my modules are working perfectly. So that's it. Thank you all for watching. See you next time. This is Paul signing off.